Welcome to the optional part 5 of the interactive plots module. Thanks for joining me. I hope you'll find this content super interesting and definitely will be some cool applications that we can use for our project. So we're going to take interactiveness to the next level and learn what is called a graphical query in the Plotly framework. So what that is we are going to use a popular approach for linking views, which are just different plots, either plots or tables, based on doing kind of behind the scenes a graphical query. So we're going to use our plots to query the data, and that's going to affect how those plots, how those data points show up in our images. So we are going to actually use Plotly to kind of interactively create queries. That's what we're going to do. So we're not going to delve into too much of the back end of how this works. We're just going to focus on the application of it. But essentially what we're doing is we are using our plot and our mouse to filter data or similar data points based on what we select. So essentially, the main thing that we need to use is the Plotly function called highlight key. So it's super, super simple. All we have to do is we take our standard Plotly scatter plot that we have here. So we take the mtcars data set and we pass it to Plotly. We have our X and our Y variable. We add points with add markers, and just to point out which type of cylinder we're looking at, because that's what we're going to highlight on, we added that label on there. So the only thing that we have to do is use this function highlight underscore key, and then the implicit argument is the data set. So we can ignore that. And what we have to do is give it the variable that we want to highlight. So I'm going to focus on the cylinders. So that is what is shown in text. So now when I run this, right, the plot looks the same, but if you notice, when I click on a point, what happens is it highlights all of these similar points. So behind the scenes, it's querying all of the data points that have a cylinder equal to the one that I have selected. So that's what's going on behind the scenes. So just a little bit of extra information for you. So when we use this highlight key and I select a point, it is selecting. So here's an SQL command if you're familiar with that. So select all of the columns from the particular data set that we supplied, so mtcars, where the variable that I have in my highlight key statement, cylinder, is in the value that I've selected for right now. Now it changes to 6. And it runs that code behind the scenes and updates our plot based on which values should be highlighted and which ones should be dimmed to the background. So pretty neat. We can add this new level of interactivity with just one line. We can also control how the selecting is done via the highlight function. So by default, it works with clicking. So I have to click a point and I can double click a point to turn it off, or double click my graph and it should turn off. We can also change this, the on event, so what changes the highlighting, to a few different options, and I'll just demonstrate one of them for you, which is plotly underscore hover. So we tell it to do the highlighting from highlight key, and then we customize how it does the highlighting based on the highlight function. So now when I run this, it is going to highlight based on a hover. So I don't have to click now. Anytime I hover over a point, it does the double clicking for us. So that's how we can use this highlight key function in its basic form. So pretty neat. So next up is we're going to take it again a step further, and we're going to use what's called linked brushing, which is just a fancy way to say that we are going to have multiple plots that are connected via this highlighting strategy. So ideally, when I highlight one object, one plot, it's going to then highlight or filter to the data table in the corresponding plot or table. So that's what we want to have. We want our two plots to be talking to each other, to be communicating through this highlight event, right? So they're linked via highlighting. That's what linked brushing is. So the very first thing that we're going to do, and we're going to use this strategy a lot, is to start with the same code. So what I have currently is the same scatter plot. So what we're going to do is modify this to create a data table that is going to filter to just the rows that I have selected. So here's how we can do that. The first thing that we need to do is create a shared data object. So a shared data object is actually what is being created behind the scenes when we do this highlight key. So we're just going to give this name, give this highlight key a name, and we're going to call it shared data. So we're just going to use this name for all of them. And I'm going to give it the data set mtcars. So what this highlight key is doing is it's creating a shared data instance, which is from the crosstalk package, right? Think of crosstalk as a way for our plots to communicate to each other, right? Crosstalk. So the shared data is just a special data type that allows all elements accessing it to communicate to each other, right? That's all the shared data is. So highlight key is just a wrapper function. So it is an easier way to call this other function from the crosstalk package. And it's important because it allows that communication piece. So once we do this, now instead of making our plot from the mtcars data, we're going to make our plot from the shared data. And then I can also get rid of this highlight key. So now I've done the highlight key, I've created my shared data, and now I'm building my plot from the shared data. And then what we have to do, so if I just run this, right, I still get my plot. So nothing really new has happened yet. But what we have to do is name this object. So I'm going to name my plot because in order for us to put two plots or two things in the same kind of panel, I'm going to use the bscalls function from the crosstalk package. So bscalls, I'm going to put my plot, and then I'm going to use a data table from the DT package. And this is also going to be built off of the shared data. So when I use data table, and then I do the shared underscore data, this should create a table next to my plot. And we're just going to specify the height of my table so that I get all of the rows that I want. And I have to run this for it to work properly in my console. So when I run this, what we get is a table. So this is what is created from the shared data. So I have a table built off of the shared data. I have a plot built off that same shared data. And when I highlight, notice that my table is filtering to just that single point that's being highlighted, right? That's what this crosstalk package is doing for us. That's what's happening behind the scenes with the shared data, is it's linked brushing. So when I highlight over a point, when I brush it, it is then being linked and shown in the other object, which we have as a table. So that's pretty neat, is we can kind of connect these two, right? This is going to be a great exploratory data analysis tool for us, and we'll actually have an application showing us how to use this to our advantage. So that is what this is doing. So next up is that application that I mentioned. So we are going to use this to further our EDA techniques. So in a true exploratory data analysis setting, we are making lots and lots of visuals, right? We have to investigate lots of follow-up questions in order to find something of interest, in order to find something valuable across our data. So being able to, with our code, easily add this interactivity to allow us to investigate these follow-up questions is going to be a really valuable tool that we can use. So suppose we are using the MPG dataset and already have set up some code for us. So let's go ahead and run this. So what we have here is, and I'm going to run this in the console again so it works properly. So what we have here is a scatter plot for the MPG data, and it's showing the displacement, which is some function of a car, versus the highway gas mileage. And then we have a data table showing the specific rows. So if you notice, right, there's a kind of general pattern. Maybe these two guys, I can lasso select here. I can figure out which points, which cars these two are. So these are all Volkswagen, so maybe I could investigate Volkswagen a bit more, see why these ones have such high gas mileage. And then there's a general trend, but then there's this group of points out here. So by using this linked brushing, it's much easier to delve into these questions as opposed to figuring out which rows all of these correspond to. In this case, it's 24, 25, 26, 27, 28, 159. And then writing a select and a filter statement to get to those, right? That's going to be a lot more work than this linked brushing technique. So what we see when we highlight this little cluster is that 5 of the 6 models are Corvettes. So there's something going on with Corvettes. So let's see which one is not a Corvette. So if I highlight now these ones, okay, so it looks like that point out here, that was the Pontiac. So these points might be worth investigating. So let's say these actually fit into my final narrative, and I want to highlight these Corvettes and say that they do not follow the trend for displacement and highway, right? That would be a follow-up question that we've investigated, and now we want to communicate that to our audience. So the next step in the puzzle would be to highlight those. So rather than relying on our audience to do that highlighting for themselves, we want to, in a static image, show that. One way that we could do that is with ggplot, and we can change the color. So I can make all of these Corvettes a red dot and all the other cars a gray dot to make them blend into the background. And the way I did that is by having just one layer of every point, and I'll give them color equals other, and then I specify that other should be mapped to gray. And then I add another layer where the color equals Corvette, but I filter the data to just those Corvettes, and I set that color to red. So pretty easy to make that in ggplot. Another option would be to annotate the points of interest, and this can be done via the ggforce package with geomark hole, or geomark ellipse, or geomark circle or rectangle. So what this is going to do is kind of add an annotation to our plot instead of coloring. So we're just taking advantage of a different aesthetic to draw attention to these Corvettes. So rather than color, we're going to use annotations. So this is going to be a super simple way to do this. All we have to do, I'll start with the ellipse. So I'll do geom mark ellipse. And what we need to do is it needs to have an X and a Y aesthetic. So I'll talk about what that is going to look like for us. But then we can actually filter. It has a filter aesthetic, and we want to only highlight the points where the model is equal to Corvette. So make sure your spelling is good there. And then we'll see what the label pops up, but we just want to label it as the model. So let me run this first so we can get an idea of what I'm talking about. So when I run this, we get an error because it's missing the X and Y aesthetics. So all we have to do is just relocate our X and Y aesthetics locally from geom point into the global ggplot. Now when I run this, here's my annotation. So we get the ellipse around the points of interest. So it gives us all of the points of interest, and it labels them based on the model, which was in the data set as Corvette. But notice this point out here is actually not a Corvette. So we have to be careful with our shapes. So if I were to change this to a circle, that now includes some shapes, some points that aren't Corvettes, right? It's drawing the optimal shape to fit around all of these. So if I try a rectangle now, that looks like that's maybe the best option. That gives us just those Corvettes based on my colored points up there. We could also do geomark whole, which gives us this kind of convex, concave image of an annotation. So either of those work, just make sure it only gives us the points that we want, right? As in another illustration, I did a static plot here, and I highlighted via geomark whole only the Audi A4s. So it gives me the best shape for those Audi A4s, but notice I get a ton of other points as well. So we want to be careful that we're only using this when we have kind of separate clusters, or else color would be the better option if I want to highlight some points that were in amongst everything else. So that is these kind of like final pieces. So we use the linked brushing in the EDA to figure out questions, to ask questions and get answers about our data. And then in the final piece, when it comes time to communicate, we use geomark whole or take advantage of ggplot's aesthetics and highlighted those points for our audience once we have already answered those questions. So a pretty neat technique for us. This idea can also help with graphical queries and combating overplotting. So one plot that we've seen before is our line plot. So there's a lot going on here. It's kind of hard to focus on one country at a time. So this idea of brushing can come in handy. So what we can do is do highlight underscore key. And whatever variable we give it, that is what it's going to focus on. So it's going to pull out the countries. So now when I run this, the plot looks the same, but I can actually click on one country at a time. So it highlights that one and dims the rest of them, right? That's what this highlight key is doing for us. So this allows me to focus on single countries, notice their trend, find other countries, notice their trend. And we can actually show multiple ones. If I hold down Shift and click, it allows me to keep several of them highlighted while I add more to my selection. So that is how we can use. So again, that was clicking and then holding down Shift and then clicking again. And that allows me, it sets persistent argument to true. So persistent equals true. Behind the scenes is what Shift clicking is doing. And that is giving us the multiple lines that are highlighted. We can also customize the results a bit more by doing the highlight function. So that persistent equals true is being set in the highlight function. But if I were to explicitly add a few other options, we can see their effect. So highlight, so the first one that I have here is dynamic equals true. Let's see what that one does. So this one gave me a color option. So now when I highlight Europe and Slovenia, it's giving me it as a red line. When I highlight Benin, it's giving me it as a red line. I can change it, and let's say I want Korea now to be a blue line. Right, I'm focusing on these countries in blue. And then the next ones I want to be green, these countries with higher life expectancy. Right, so that's what the dynamic does. It gives us this color option. But let's say it's really hard to find a particular country that I want, right? I have to scroll through here really quickly and have a really quick eye and recognize which country I'm looking for. We can make it a lot easier on ourselves if we use the selectize equals true. That gives us this drop down. Now I can type in, let's say I'm looking for the United States, gives me that drop down, and I can again hold Shift and highlight several of them, change the color, highlight a few more. So that's how we can take advantage of these really easy tools to add some pretty neat features to our interactiveness. And we still get all the default interactive from Plotly. So I can just show the non-African countries. I can take away the Americas, just focus on Europe. And then maybe within the Europe, I just want to look at Turkey, Slovenia, and Ireland, right? We can use all those default interactive features as well. So this allows us to focus on specific comparisons of interest, right? Revealing some more finer aspects of our data. It's pretty neat. So there is an exercise for you to try. So next up is linking multiple plots. So we saw how to link a plot in a data table. Now we're going to link multiple plots. So a very common strategy in DataViz is to show two plots. One of them is going to be an aggregated data plot, and then the other one is going to be a finer detail. So a scatter plot, for example. So this gives us kind of the popular flow of an overview from the aggregated plot. And then we allow with the interactiveness to zoom and filter and give us the more detailed plot that we want on demand. So that's what we're going to do. So to do this, what we have to do is first we'll take a look at the two plots that we have. So I just have a bar graph for the cylinder and then a scatter plot for the MPG by weight for the MT-CARS data. So the first thing that we're going to do is actually organize these plots with the shared data. So we're going to use the same strategy as we did with the table. We need to create a shared data object. The shared data, we'll do highlight key again. And we'll give it the MT-CARS data. And then I'm going to build my plots from the shared data rather than the MT-CARS directly. So that's step one, is creating that shared data. Next up, we need to name our plots. So save them as an object so that we can call them in the function that we're going to use to organize them. And instead of BS calls to organize them that we used with the data table and the plot, we are going to use subplot. So subplot is going to be a way that we can just organize plots. They could be static plots, or we can use them with the shared data plots as well. So if I just do subplot, this is from the Plotly package. I can do P1, P2, and this organizes them now side by side. And because they're based on the shared data, when I click on one bar, it highlights the other points that match this cylinder. So these points are by cylinder. So I'm getting all of the 4 cylinder cars highlighted in my scatter plot. Now I'm getting all of the 6 cylinder. I can also click on an individual point and it shows me which cylinder it has. So this Mercedes 240D has a 4-cylinder engine. So that's how we can use the shared data with subplot. But we can also kind of spruce up our plot a little bit. So notice when I click this, I get a really ugly legend. So that legend doesn't really add anything. So what we can do is we can now pass some functions to our subplot rather than the individual plots. So if I pass the function, the subplot to the function hide underscore legend, that's going to get rid of that legend. Now, when I click on the points, the legend is gone. We can also add in some other features that we saw with our highlighting. So highlight, now let's say I want to get those different colors so I can compare the colors for the different cylinders. So I'll do dynamic equals true. So now I have all of the 8 cylinders in red, and I want to show the 4 cylinders in green. All right, so that's the dynamic true. So we can use that for our subplot as well, and it applies it to both of them. And then we could also do selectize, set that equal to true, and that'll give me my drop down. So now I can select the different vehicle types. So notice with select ties, we didn't, with our highlight key, group by anything. So by default, if we haven't grouped by anything, right, when we were up here, we grouped by countries. So when I did select ties, it gave me the countries. When we're down here, we haven't grouped by anything. So what it does is it gives us the row names by default. So the row names for the empty cars data set are all of the actual vehicle names. We can also notice how this says shared data and then a long ugly string. So we can customize that name by doing 2 commas because we need to skip the second argument, which is the variable. And we can do select a model. When I run this now, it changes the name of my dropdown to select a model. So that's how we can use this linked brushing on 2 separate plots and do some more customization as well. But we can also use subplot when we aren't doing the linked brushing. So let's say I wanted to use subplot for some comparative box plots. So let's take a look at what we have first. So let's just run this code. So this gives us a base plot of Plotly, was going to be the diamonds data set with the Y variable as the price. So on my Y axis, I have the price with the default color and blended a little bit for the outliers. And then we're going to take that base plot and we're going to add box plots, one for the overall. So that gives me my x-axis is overall. It doesn't group it by anything. And then we have it by cut. So this gives me the box plots for every single cut. And then when I subplot, by default, it gives it to me side-by-side panels. So there's a lot of customization that we can do for our subplot. So here is a quick demonstration of a few of them. So notice that we have this repeated y-axis that is the same for both of them. So what we can do is do share y and set that equal to true. When I run that, that gets rid of the middle y-axis and lets them have the same exact y-axis. We can also change the widths of our columns so that the overall box plot is the same width as the regular box plots, as the other ones. So to do that, we'll just set the first pane to 0.2 and then the other one to 0.8. So it's relative to 1 is the total. Now when I run that, now the box plots all have similar widths. So we get an overall picture and then broken out in more detail. And we can also get rid of this trace, right? That doesn't add anything. So we can pipe that to hide legend. And that will get rid of the trace for us. So there's one example of how we can do some customizations with our subplot function. We can also do some more customizations and add a linked brushing to subplot again. But first, we'll just focus on the customizations. So I have 2 different box plots or 2 different types of plots here. So I have a density curve for each of the different diamond cuts. And then I have box plots for all the diamond cuts. So we want to show both of these at the same time. The density curve will give us a really good image of the shape, whereas the box plots give us an idea of the center and if there's outliers. So combining these, we'll get a really good understanding of these distributions. So what we can do is we'll do subplot P1, P2, and just take a look at the default. So put them side by side. So both of these are kind of long images in terms of their width. So rather than stack them side by side, let's have 2 rows. And this will stack them on top of each other. So now we get a much better, a much cleaner image, not as cramped. But then again, notice we have now this repeated x-axis. So similar to y, we can use share x, set that equal to true. And then this gives us the box plots with a shared axis now. And notice in my first plot, I'm using ggplot. And in my second plot, I'm using Plotly. So we know Plotly gives us that interactiveness. Subplot, because it's from the Plotly package, actually gives our ggplot that interactiveness. So I didn't have to convert this to ggplotly. I already get that by default when I'm using the subplot. Next thing that we can do is add the shared data. So notice when I'm clicking through here, the bottom plots are remaining the same. So what I can do is just show or highlight when I click on the fair, I can highlight the fair to emphasize their box plot. So to do that, all we have to do is use, again, the same technique that we have been using. Shared data, we'll give it the highlight key, and we'll call on the diamonds data set. And then I just need to create my plots from the shared data rather than the diamonds. And now when I run this, it takes a moment. The plot looks the same, but now when I click on the fair density curve, it highlights the fair box plot. And I can highlight multiple of them. So let's say I want to look at the ideal, and I'll shift click and look at the fair versus the ideal, and it dims the rest of them. So that is a pretty neat way to use subplot and that linked brushing again. So there is a good exercise for you to try with a really long solution. So the last thing that we're going to learn for the interactiveness is going to be the highlight versus filter events. So we demonstrated this at the beginning of the first video. When a highlight video, this is what we have been doing, or a highlight event, we have been doing this, where it highlights the one that we want and dims everything else. A filter event is different. When I click on a specific city now, it is actually getting rid of all the other data, rescaling the axes, and just showing it for the specific cities that I'm looking at, right? That's what's happening behind the scenes, is it's really getting rid of all of that other data, rescaling it, and just showing me the data points that I've selected. So that is what a filter event is versus a highlight event. So we have just been working with highlight events. So now we're going to cover how we can make this filter event. So here's how we can do that. To do this, we're going to use the Crosstalk package. And what we have here is just our data set already created as a shared data. So let me just run the code to show you the plot. So this is just a static image of the plot. So to do this, we need to have our object named. So I have the shared data as the highlight key of the Texas housing data set. And then I create my static plot from the shared data. So same strategy that we just saw. And then we'll do this in pieces. To create, we're just recreating this right-hand side. The first thing I need to do separately is create this filter bar. So before we got this bar in here with select ties, we actually have to call a function to get this filter bar in here now. So to do that, we need to use the function filter underscore select from the Crosstalk package. So filter underscore select, and here are the arguments that we need. So what we're doing here is essentially creating a filter widget, which is just like an HTML element, which we're creating that bar. And we have to do that from a Crosstalk function. So it expects as an argument the shared data, which we get from our highlight key, but we have to give it an HTML ID. So we'll just call it ID. That's kind of irrelevant for our purposes. The label is what is going to be called up here. So I want it to be select a city. select a city, and then it expects a shared data. And we conveniently named ours shared data. And then the group, so this is going to be the values that show up in the dropdown. So for the Texas housing data, we are grouping by city. So we give it a formula, symbol with the tilde, and then the city. So when I run this, all right, that's just giving me this bar. So all we've done is create this filter bar. So then we actually have to add that to our plot. So to do that, we can use the same function bscalls that we saw with our original linked brushing. So I have now the bscalls with the filter select, and then I need to add my plot. So I'll call P, run that, and we get an error because this one needs to be converted to ggplotly. So once I convert this to ggplotly, now I get my filter bar and my plot that is filtered based on the points that are the cities that are selected. So one thing that we can do is reorganize this a bit. So I can set the widths in bscalls. The maximum width is 12. That's just going to put them on top of each other. So now each element has width 12, and now it's organized much better. And I can highlight, actually filter to certain cities of interest based on my filter bar. So that's a really neat application, kind of taking that interactiveness to the next level. So there's one more exercise for you to try, and that is it for this video. So thanks for watching, and I hope you'll find value in this and be able to use it in your guys' project. I will see you in the next video.